Welcome back. Next, we will be discussing about the experiment number 2, that is dimensionality reduction for word embeddings using PCA or TSNE. PCA means principal component analysis, and TSNE, the full form of TSNE is T distributed stochastic neighbor embedding. And now I am going to explain this program. First, in this experiment, um, it demonstrates dimensionality reduction techniques like PCA and TSNE to visualize word-to-vec word embeddings. First line, this pip install Gensim NumPy Matplotlib Scikit-learn. It is all the libraries we have to install. Next, import libraries. We have to import the libraries like Gensim, as I previously said. It is for modeling and word vectors. NumPy is for vector representation. Matplotlib, it is for graph purpose. And Scikit-learn, it is a machine learning and statistical modeling in Python. Also in a short abbreviation called sklearn. Next, import Gensim downloader as API, import NumPy as NP, import matplotlib.pyplot as PLT, from sklearn.decomposition, import PCA, from sklearn.manifold, import TSNE. We use these many libraries. We import these libraries like we import Gensim for word to vec. We import Gensim for word to vec, NumPy for numerical operations, Matplotlib for plotting the graph, for plotting the graph, PSNE and TSNE, it is for dimensionality reduction. You should keep in mind when you type this program, when you are learning this program, you should keep this mind in that PCA and TSNE are used for reducing the dimensionality. Next come loading pre-trained model. Loading pre-trained model. In experiment 1, we have learned this pre-trained model. We have used word to vec Google News 300. Here also we use the same pre-trained model, that is Google. That is word to vec Google News 300. What it does, this loads the pre-trained word to vec Google model trained on Google News data. This Google News data 300, it will be already pre-trained in the Google News data. Next, this is the word relationship function we have used in this program. It performs vector arithmetic and find similar words. See, this function, it performs word vector arithmetic operations. That's it. Next, this is the vec1, vec2, vec3. That is word vectors of word 1, word vectors of word 2, vec3 is equals to word vectors of word 3. We find the result vector of all these vec1, vec2, vec3. That is vec1 minus vec2 plus vec3. In previous experiment, we have used words, right? Like word 1 minus word 2 plus word 3. In the same way, vec1 minus vec2 plus vec3. Here we use this. Here we perform vector arithmetic like king minus man plus woman. In the same like. Next, similar words. Similar words is equals to word vectors dot similar by vector. You know this word vectors and similar by vector. It is for similar words is to find the similarity between the words. Similar by vector, it is used to find the similarity between the two vectors. Of similar by vector of result vector comma top n is equals to 10. This This line, it is used to find words closest to the resulting vector. This finds which are the words closest to the resulting vector. And next, input words, we just give input words word 1 comma word 2 comma word 3. Filtered words, word comma similarity for word comma similarity in similar word. If word not in input words, that's it. Print slash and word relationship, word 1 minus word 2 plus word 3. Next, we are going to print more similar words to the result of excluding input words. For word comma similarity in filter words of colon 5 is the size. Print of f word colon similarity colon 4 dot 4f. Written filtered words. Next, except key error as e. Print f error e not found in the vocabulary written. If exception arises, print e not found in the vocabulary and written. Next, similarity function. This is similarity function. Def analyze similarity of word 1 comma word 2 colon. What it says? It says this function calculates similarity between two words. See, analyze similarity means it will just calculate the similarity between two words, that is word 1 and word 2. Try. Similarity is equals to word vectors dot similarity of word 1 comma word 2. It computes the cosine similarity score. That means it will compute the similarity between word 1 and word 2. Next, print of f slash and similarity between word 1 and word 2 colon f similarity colon dot 4f. Same. Next comes this and all same. I don't need to explain, right? Next, the PCA and TSNE function. See, this is the PCA and TSNE function where it starts from def visualize word embeddings of words, comma vectors, comma methods is equals to PCA. Def visualize word embeddings of words, comma vectors, comma method is equals to PCA. This function visualize word vectors on a 2D graph, two-dimensional graph. Okay. If method is equals to PCA, reducer is equals to PCA of n components is equals to 2. If we want how this n only two components we have taken, right? N components is equals to 2. So there will be two components. If method is equals to TSNA, reducer is equals to TSNA of n components is equals to 2, random state is equals to 42, perplexity is equals to 5. And hence colon raise value error method must be PC or TSNA. If else raise value error. Next, this reducer is equals to PC of n components is equals to 2 means it says PCA reduces 3 dimensions to 300 dimensions to 2 dimensions. Okay. In Google News 300 dimensions we have to. It will in this reducer what does it do? It will reduce 3. Wait, yeah, reducer. What does it do? It reduces the 300 dimensions to 2 dimensions. PCA. Okay. Next, TSNE part. In the TSNE part, reducer is equals to TSNE of n components is equals to 2. That means TSNE, it will group. So TSNE, what does it do? It groups similar words together for better visualization. Whereas PCA, it reduces the 300 dimensions to 2 dimensions. But TSNE, it reduces, sorry, it doesn't reduces, it will group the similar words together for better visualization. Okay, TSNE for better visualization, but whereas PCA for reducing the dimensions. Okay, So it will give dimensionality reduction. Next has error reducer vectors. Reducer vectors is equals to reduce dot fit transform of vectors. PLT, we are plotting the graph. So PLT dot figure of fixed size is equals to 10 comma 8. You can take this like a 12 comma 4, anything you can take this number. For I comma word in enumerate of words, PLT dot scatter, we are going to plot this graph in the scatter form. Reduce vectors of I comma 0. And next PLT dot title, what we are going to name word embeddings visualization using method dot upper. And as we have said, component 1, component 2. PCA, it is going to reduce the 300 dimensions to 2 dimensions, right? So we will have component 1 and component 2, and PLT dot grid of true, PLT dot show. Here explore word relationships. PLT dot scatter, what we use PLT dot scatter for? PLT dot scatter. We use PLT dot scatter to point in the graph. To point the plot. What it plots? PLT dot scatter. Scatter. It is used to plot each word as a point in the graph. Okay. It will point each word in the graph as a point. Next, it has over. This is all over. Next, explore word relationships of king, man, man, woman. It will say the model predicts queen because king is relates to man. Similarly, queen also relates to woman. See, both are similar gender wise, like king and man are similar, queen and woman are similar. So the model predicts it.